Hello, my lovely Algebra 1 kiddos. So today we're going to be talking about using all this rational expression mumbo jumbo we've been working on all week and all month actually, and we're going to apply it to real life situations and look at some different types of word problems. So the video today is going to talk about working together word problems, and it's also going to be talking about number word problems, okay? So first we're going to look at when we work together on things. All right, so let's just pretend that we have, Mark does his homework in, an hour, and John does his homework in an hour and a half. If I told them that night they could do their homework together, do you think that it would take longer or it would be shorter? Okay, I'm hoping that you're thinking about that for a second. When people work together or they do a job together, two people is always going to be better than one. So it's going to be less time. Well, we can use that concept to help us solve problems with rational expressions. We can use rational expressions in a little bit of a different way. First of all, I want to talk about the word together. Okay? When people do things together in math, usually the word together indicates that we're going to add something, okay? We're going to add them together, okay? So let's look at our first problem. It takes crew A 6 hours to build a wall. It takes crew B 8 hours to construct a wall of the same size, okay? So they have to be doing the same size if we're going to compare them. How long will it take them to build a wall if they work together? So if they build a wall that's the same exact size. All right. Well, the way I like to look at this is instead of looking at how long it took them to do it in 6 hours, I'd like to think of how much have they completed in 1 hour. All right, so if they completed the job in 6 hours, then in 1 hour, crew A completed 1/6 of the job, okay? Crew A in 1 hour, okay? So 6/6, that would be how much of the job they completed in 6 hours. Okay, so 1/6 indicates crew A. Crew B, if it takes them 8 hours to construct a wall, then in 1 hour they did 1/8 of the job, okay? So that would be crew B. It wants to know how long it will take them to build it together. So that means I'm going to add. Now the question is, how are we going to make this an equation? Well, we're going to make this equation by figuring out, we want to know the total time it would take them together. So we're going to use a variable. I'm going to work with T. If T is the number of hours to complete the job, and we just broke these guys up based on 1 hour, then in 1 hour they would have completed 1 T over T of the job. And there now we have our rational equation. Okay, so how do we solve our rational equation? Now you guys have written this below each of these pieces, these segments. I'm going to erase it so that I can do the work on the same page without scrolling. Okay, how do we solve a rational expression? Well, we worked on this yesterday. First we find our LCD, okay? And our LCD in this case would be, we look at the lowest common denominator. So let's see, is it 24T? So my LCD is 24T, okay? So I multiply every piece of the expression by 24T. All right, and then I simplify. 6 goes into 24 4 times. 4 times T times 1 is 4T. 8 goes into 24 3 times T, and then also times 1 would be plus 3T. T goes into T, okay? So those cancel, and you'd be left with 24 times 1, which is 24. All right, now this looks like a much easier expression. So we get 7T equals 24, okay? We divide by 7, and so T equals 7 into 24 would give me 3 and 3/7, okay? 3 3/7. Okay, so that's telling me that it's going to take them together 3 3/7 of an hour. So 3 hours and 3/7 of an hour if they work on this project together. So let's just remind you, it took crew A 6 hours, it took crew B 8 hours. So when they did it together, look, it took them a lot less time, okay? All right, let's look at another example. So the next one on your worksheet. Mark can mow a lawn in 18 minutes. David can mow a lawn of the same size in 24 minutes. How long would it take them if they worked together? Okay, so again, that word together tells me I'm going to be adding something. Now I'm going to look at this a little bit different. This one's working with minutes, not hours. So I'm going to break everything up into 1 minute. All right, so how much can Mark do in 1 minute? He can do 1/18 of the job. Okay, how much can David do in this? David, it takes him 24 minutes. So in 1 minute, he can do 1/24 of the job. Okay, and then if they work together, how long would it take them to work together? So T again, we're going to use as the total time to do the work. So how long would it take in 1 minute? It would take 1 of T. Okay, very similar to what we did in the last problem. All right, now we've got to find the LCD. Okay, finding the LCD with 24 and 18 is a little bit harder. Okay, so I want you to think about that for a second. Let's see if we can come up with it. We want the lowest number that they both go into. So again, you can write down your multiples. 18, 36, 54, is that right? 72, and then 24, 48, and I guess that's 72. Good. So 72 and 72, so my LCD would be 72, but I can't forget that T. Okay? All right, so I'm going to erase that. Now we multiply everything by our LCD of, let me change colors, of 72T. There's one right there, so I'll leave it. And I'll multiply this by 72T. Okay. All right, so what do we got here? We get, all right, 18 goes into 72 4 times, so 4T, plus 24 into 32 is 3T, and that equals, the T's cancel, that equals 72. Okay, so we get 12T equals 72. And we divide by 12. I'm sorry, 4 plus 3T is 7T. I made a mistake there. Let's back up. So 7T equals 72. And then we divide by 7, and we get T equals 10 and 2/7. Okay, so it's going to take them 10 and 2/7 minutes. 10 and 2/7 minutes if they work together. So now I want to look back again, all right? So let's just talk about it. We broke this first question, we broke it down into hours. So in 1 hour, we could do 1/6 of the job because the job took a total of 6 hours. This one, 1/8 of the job. But again, we did this question in hours. This one, we decided since the question was given in minutes that we'd break it up into 1 minute. Okay? We then solved the rational equation using the process that we learned yesterday by multiplying everything by the LCD. All right, now let's look at one that you guys can work on. John and Paul have to paint a 10 by 10 room quickly, and they decide to work together. John normally can paint a 10 by 10 room in 2 hours. Paul can normally paint the 10 by 10 room in 3 hours. How long will it take if they work together? Okay, so what I'd like you to do is based on the last 2 examples, I want you to try it. I'm going to do the work on the board, and then I want you, so pause right now, and then come back and check your work, okay? All right, so John can do the job in 2 hours. So in 1 hour, he can do 1/2 of the job. Paul it takes 3 hours, so in 1 hour, he can do 1/3 of the job. So if they work together, again, I'm going to add, it would be 1T of the job. I multiply by the LCD. The LCD in this case would be 6t. So I multiply 6t to everything. This is going to help me clear the fraction, remember. So 2 goes into 6 3 times, so I get 3t. 3 goes into 6 2 times, so I get 2t. And the t's cancel here, this equals 6. All right, so I get 5t equals 6. I divide by 5, and I get t equals 1 1/5 hour, okay? So that's how long it's going to take, 1 1/5 of an hour. Hours. Okay? So tomorrow we're going to do a couple more practice problems on these, and hopefully you guys will start to feel a lot more comfortable with them, okay? All right, next we're going to look at reciprocal problems. First of all, let's review what the word reciprocal means. Reciprocal, if I give you the number 2, its reciprocal would be 1/2. It means to flip it. If I give you a number 2/3, then its reciprocal would be 3/2. And if I just say, okay, a number, x, or sometimes we like to use n, okay? If I say n, we'll use n, its reciprocal would then be 1/n. Okay, so looking at this problem, it says the reciprocal of 2 less than a number is twice the number. Okay, so we've got to do 2 less than a number. What is 2 less than a number? 2 less than a number would be n minus 2. Not 2 minus n. This is 2 less, so taking away 2 from a number. I want its reciprocal. So if I want its reciprocal, I need to write that as 1 all over n minus 2. Okay? Is. We know that is always means equals. So this is going to equal twice the reciprocal of the number. Okay? So the reciprocal of the number, if n is the number, its reciprocal is 1/n. Twice that means 2 times it. So 2 times 1/n. Now I can simplify that to 2/n. So it would be equal to 2/n. All right. Now, again, it's a rational equation, so we multiply both sides by the LCD. Okay, so our LCD is n minus 2 times n. Remember, it's got to be the product of all the denominators, okay? So I'm going to multiply this by n minus 2n, and I'm going to multiply this side by n minus 2. All right, the n minus 2's will cancel, so we get n. The n's will cancel, so we get 2 times n minus 2. Now at this point, we don't want to forget that we have to distribute that 2. So we distribute our 2, and we're going to get n equals 2n minus 4. Okay? So I'm going to bring the 4 over to the other side and the n over. And I'm going to get 4 equals n. All right? So what's the number? The number is 4. Okay? All right, let's do one more like that. Let's look at the next one. The reciprocal of 2 more than a number. And I just want to check to make sure you guys can see everything clearly. Okay, the reciprocal of 2 more than a number. Okay, so we have to do the 2 more than a number first. 2 more than a number is n plus 2. More than means add. All right, I want the reciprocal of it. Reciprocal means flip it. So if I take the reciprocal of n plus 2, it would be 1 all over n plus 2. Have to do this in parts, have to think about this carefully. Is. What does is mean? Is means equals. 3 times the reciprocal of the number. Okay, so the number is n. Its reciprocal is 1 over n. 3 times 1 over n is going to give me 3n. 3 over n, sorry. 3 over n. Look at that process again. N's the number. 1 over n is the reciprocal, because we flip it. 3 times it means to multiply by 3. And then I clean that up to give me 3 over n. Okay? Now, we multiply both sides by the LCD. Our LCD is n times n plus 2. Okay, the product of those denominators. So So n times n plus 2, we multiply it on both sides. Okay? The n plus 2's here cancel, we get n. The n's here cancel, we get 3n plus 6. So I distributed it in one step here. Now, I subtract n on both sides. And I subtract 6 to the other side. All right, so we get negative 6 equals 2n, and we divide by 2, and so n equals negative 3. So our number is negative 3. All right, awesome. Let's look at the last one. The reciprocal of 4 plus the reciprocal of 5 is equal to the reciprocal of what number? This one's a little bit harder. You may want to try it on your own if you're feeling comfortable with it, okay? All right, so the reciprocal of 4. What's the reciprocal of 4? If 4 is the number, its reciprocal then is 1 over 4. Okay, plus. You know what that word means. Plus. The reciprocal of 5. So if 5 is the number, then its reciprocal is going to be, flip it, 1 over 5. Is the reciprocal of what number? Well, if n's the number, its reciprocal is 1 over n. So that looks like what we've been working on a lot too. It's, again, a rational equation. So we multiply everything by the LCD, but now we got to find the LCD, okay? So we look 4, 5, and n. So what's the lowest number 4 and 5 both go into? That's 20. So my LCD would be 20n. So I'm going to multiply everything by 20n. The n's cancel here, I get equals 20. 4 goes into 25 times, so I'm going to get 5n. 5 goes into 24 times, so 4 times n times 1 is going to give me 4n. I add my numbers together, so I get 9n equals 20, and I divide by 9. So n is equal to 29ths. I know, not a pretty number, but it is a number, so it does work. All right, so tomorrow in class, guys, we're going to practice all this, so come prepared. If you need to watch through this video again, please do so. Just to make sure that you feel comfortable with these two types of word problems. We're going to practice it all tomorrow, and I will see you tomorrow in class. Thanks for paying attention. See you tomorrow. Bye.